To solve quadratic equations using factoring, you need to have a couple conditions met. First off, you need to have your equation in factored form. That means you need to have factored it out, gotten it into those parentheses. The second thing you need is you need to have your equation equal to 0. Sometimes you need to do some work in order to get that to happen. So let's look at a couple of examples that are already set up for us to solve using factoring. Say we had 5x plus 1 as one factor, we had x minus 3 as the other factor, and this equation equals 0. We want to solve this equation for x. By the zero product property says that anything times something else, if that equals 0, one of these two things needs to equal 0. So to solve using factoring, we rely on the zero product property, and what we do is we set each of our factors equal to 0. We're going to find out what number would make 5x plus 1 equal 0, or what number would make x minus 3 equal to 0. If you look at these two things, we really just have a couple of simple equations that we can solve using our do and undo, or just isolating x. Subtract 1 from both sides. So you get 5x equals negative 1. Divide both sides by 5. So you get x equals negative 1/5. So one of the solutions to this quadratic is x equals negative 1/5. If we look at the other factor and we solve that one, all we have to do is add 3 to both sides. So we get x equals 3. So this quadratic has two solutions, or two x-intercepts, and those two x-intercepts occur at 3 and negative 1/5. Here's another one that's already set up, ready to go for us. It's been factored and it equals 0. So we need to set each of our factors equal to 0 using the zero product property. Now x plus 7, that one's easy to see. Oh, x plus 7 equals 0. But there is a second factor in this problem with x. It's x. So we also need to find out when x equals 0. Well, haha, this is my favorite factor because look, x equals 0 when x equals 0. Done. One of your x-intercepts is 0. We do have to solve a little bit on the 7, and so I'm going to subtract 7 from both sides, and we get x equals negative 7. So our two solutions, or our two x-intercepts in this case, are 0 and negative 7. So even if you don't have two sets of parentheses, that x still counts. It's still part of your solution. Now, the trickiest part of solving by factoring is not this part that we just did. The trickiest part is actually doing the factoring. So I'm going to do a few examples where we have to factor, and then we'll solve by factoring. So remember, we had two conditions when we needed to solve by factoring. We needed to get it in a factored form, and we also needed it to equal 0. This problem doesn't equal 0. I need to make it equal 0 by subtracting 18 from both sides. This way I have x squared plus 3x minus 18 equals 0. And this is the problem I'm going to factor, or at least try to factor. What's nice about quadratics is that there's lots of ways to solve them. So if you can't figure out what the factored form is, you can try another method of solving. But since we're focusing on solving with factoring, we know this is going to work. You can draw an area model for this one if you want, or you can see that it's one of the regular trinomials where we look for the numbers that multiply to be negative 18 and add together to be positive 3. So we think about all the factors of 18, 2 and 9. Is there any way to combine those to get 3, negative 2? Does that work? Nope. Other factors of 18. How about 6 and 3? Which one of those would have to be negative in order for me to get a positive 3 as the addition result? It would have to be negative 3. So, positive 6 and negative 3 are my two numbers for my factors. When we write our factored form, we're going to have x plus 6 times x minus 3. If you forgot about factoring, you might want to look at that factoring video again. It's on the factoring page, or you can just check out the channel. Now that we have our two factors, we're ready to actually solve this. We're going to find when x plus 6 equals 0, and we're going to find when x minus 3 equals 0. Solve x plus 6 equals 0, you get x equals negative 6. That's one x-intercept, or one solution. Solve x minus 3 equals 0, and you get x equals 3. That's our second solution. So, solve by factoring says you need to have it equal to 0, you need to get it into factored form, and then you solve each factor for 0. Solve by factoring, that's our goal. We want to have it equals 0, we want to get it in factored form. This one equals 0, so we're good there. It's not in factored form yet, though. Now, if I look at this, we see that I have an a that's not equal to 1, and I don't see a GCF, which means this is a problem that I would probably want to factor using grouping. So factor using grouping says that I'm going to split up that middle term, and I'm going to solve 2x squared plus something times x plus something times x plus 15 equals 0. So, just like when we did grouping before, we're going to try to think of some numbers that multiply to be 30 and add to be 13. Ooh, 10 and 3. So 10 goes in one blank and 3 goes in the other. Doesn't matter which one, you're going to end up with the same result. So I have my two groups, I'm ready to go. We look for a GCF in each group. For 2x squared and 10x, it looks like they have 2x in common. And what is left over is the factor x plus 5. 3x and 15, they have 3. And what's left over is x plus 5. So thinking about how we factored by grouping, we found the common factor, which was x plus 5. And then what was left over was the second factor, equals 0. Now we have a problem just like the very first one. We just need to set our two factors equal to 0. So we're going to find out what makes x plus 5 equal to 0, and we're going to find out what makes 2x plus 3 equal to 0. X plus 5, that's that easy kind, so we get x equals negative 5. So one of our solutions, or one of our x-intercepts, is x equals negative 5. The other one, we have to do a little bit more work. 2x equals negative 3. Divide both sides by 2. So x equals negative 3 halves is the second solution, or the second x-intercept for this equation. Is this one ready to be solved by factoring? Not quite. Remember, we need equals 0. I don't have equals 0 in this case. I could get equals 0, though, just by subtracting 14x from both sides. So then I end up with 7x squared minus 14x plus 7 equals 0. So I'm ready to think about factoring. Now initially when you look at this, you see a doesn't equal 1, but you don't have to use factor by grouping yet, because 7x squared, negative 14x, and 7 all have a GCF. The GCF is 7, so let's factor that out first. That means we're going to divide all of the terms by 7. We'll end up with x squared minus 2x plus 1 equals 0. Now, we can factor that middle trinomial our normal way. We're going to think about the numbers that multiply to be the last one, which is 1, and add to be negative 2. This is kind of tricky because not very many numbers multiply to be 1. 1 times 1 multiplies to be 1, but does that add to be negative 2? Nope. But if we had negative 1 times negative 1, that one works. So when we factor this, we're going to get x minus 1 as one factor, and we're going to x minus 1 as the other factor. Remember, we can write this as 7 times x minus 1 squared equals 0. Either way you write it, it doesn't matter, because you're going to have x minus 1 equals 0 twice. So if x minus 1 equals 0, you get x equals 1. If you do it a second time, you're still just going to have x equals 1. So this parabola only has one x-intercept. It hits the x-axis at x equals 1. Still want to do one last solve by factoring problem because, well, I like to factor. This one is already equal to 0. So now we need to factor it out. But a is not equal to 1. In fact, a is negative. And whenever we do our factoring, we do not want to start with a negative. So the best thing to do is to factor out the negative before you do anything else. That means we're going to divide everything by -1. We're going to factor it out. So we get -1 times 2x squared minus 7x plus 5 equals 0. Now let's look at that inside factor, or that inside. 2x squared plus 7, or minus 7x plus 5. That's what we're going to factor by grouping. So we're going to split up our -7x, and we're going to have 2x squared plus something times x plus something times x plus 5. So now we're going to think of numbers that multiply to be 10 and add to be -7. 5 and 2. But 5 times 2 is 10, but is 5 plus 2 -7? No. But there was a clue. 5 plus 2 is regular 7, positive 7. So we could just say -5 and -2. That one works. Now I'm going to fill those into my blanks, -5 and -2. It doesn't matter which order you put them in, you will end up with the exact same factors at the end. So factoring out the GCF, looks like x is the only GCF for the first pair. So we end up with 2x minus 5. There's no GCF for the second pair. But it starts with a negative, so I know I can at least factor out a -1 and get 2x minus 5. So we write down what is the same, 2x minus 5. What is left over, x minus 1, equals 0 because we're solving, and that -1. Now we're ready to solve. -1 equals 0. If the factor does not have an x in it, we don't need to consider it because -1 doesn't equal 0. It doesn't affect our solutions at all. We do need to solve the other two, though. 2x minus 5 equals 0, and we need to solve x minus 1 equals 0. I need a new color. So I'm going to add 5 to both sides for this one. You get 2x equals 5. Divide both sides, and one of your solutions is x equals 5 over 2. We can get the second solution by adding 1 to both sides for the second factor, and you get x equals 1. So this parabola has two x-intercepts. It has an x-intercept at 1 and another x-intercept at 5/2. Solving by factoring. First, you need to get it to equal 0. Then you need to get it in factored form. And last, you set each factor equal to 0 and solve for your solutions.